Hello everyone, welcome to the University of Michigan Robotics program. Today, I'm very pleased to be here to introduce the Progress Lab to all of you guys. First of all, our lab's name Progress is short for Perceptive Robotics and Grounded Reasoning Systems. So our lab is directed by Dr. Chad Jenkins, who is the full professor in the CSE department and also an associate director of Robotics Institute. So this is our working place, which is in the BEB building, sitting at 12. In majority of our time, we are working in this place with two Progress Fetch robots, Cookie and the Oddjob. Currently in our lab, we have 8 PhD students working in different areas. And let's see what they say about working with robots in the Progress Lab. Hello everyone, welcome to Michigan. My name is Zheming Zhou. I'm currently a 4th-year PhD student working with Professor Chad Jenkins in Progress Lab. So my research covers robotics perception for manipulation with focuses on line field perception and object pose estimation. More specifically, my research tried to enable the robot to interact with transparent and translucent objects. As you may know, the current widely adopted robot perception sensors and algorithms are struggling to dealing with IoT to perceive those transparencies and translucencies in our daily lives. For example, here we give 2 examples of the transparent cup, for example, transparent cup and the glass straw. My work uses line field perception to enable a robot to perform several robot manipulation tasks over challenging objects. One example is our robot can build a champagne tower for you. So in this demonstration video, there are 5 transparent champagne cups laid on the white table, which is very textureless. And with our method, we can accurately locate each of them, and then the robot can find the grasp pose for each of them, then also as well as the place pose. Then the robot can grasp picking and place all of them and putting and arrange them into a champagne cup. Cheers. If you are interested in my research, feel free to contact me. I'm always eager to talk about the new ideas and the robot. Last but not least, stay safe and go blue.
Hi everyone, my name is Xiaotong Chen. I'm currently a 3rd-year PhD candidate in the Robotics Institute of University of Michigan. I'm here working with Professor Chad Jenkins on robot perception for manipulation, and my research lies around questions in perception view for robot manipulation. Basically, we develop methods to help robots understand the environment based on their visual sensing information and take actions that are robust to changes. So these are my previous research projects focusing on robot perception for manipulation. So my projects took a common framework that uses a combined discriminative generative method on adversarial perception. So the first stage is to train a deep network that gives probability prior from observation, while the second stage employs particle filters to sample and converge to the final object pose through iterations so that we can get robust results. So these examples show the efficacy of the system in dark environment and transparent object perception scenarios. So my current project is focusing on a new affordance representation for robot manipulation. So take this mug as an example. We aim to try extract common geometry composition of mugs as a handle and the mug body, while the key points and axes on each part tell us how robot gripper to handle them or pour liquid from them. So this project is developing a deep network to learn this representation directly from RGBD images and generative actionable robot trajectories based on the estimated key point and axis. So this is currently I'm working on. And to the new student, I wish you have a good start, especially for this hard pandemic time area. So I really wish you have a safe and good start here. Go Blue.
Hi everyone, my name is Yana Pavlasek. I'm a third-year PhD student in robotics, and I work in the Laboratory for Progress. My research interests are in perception for robotic manipulation, including object pose estimation and scene understanding. My work focuses on enabling robots to function in challenging real-world environments. For example, to use these tools, the robot needs to be able to localize them in a cluttered environment. Some of the tools are occluded in the image, which makes this problem challenging, and some also have articulations, which create additional challenges by adding dimensions to the problem. To solve this problem, we represent this object as a graphical model, and we do graph-based inference to infer the belief over the object pose. We use state-of-the-art deep learning techniques to inform the inference based on the robot's image observation. And this allows us to leverage the benefits of generative methods as well as deep learning. By maintaining belief, our estimates are more robust to noisy estimates or occlusions, which are common problems for deep learning methods. This allows us to get good estimates, even in difficult cluttered scenes. If you're interested in my work, please feel free to reach out over email or check out more information on my website. Thanks for your attention.
Hello, everyone. My name is Emily Sheets. I am a third-year PhD student in computer science and engineering. I work with Professor Chad Jenkins in the Laboratory for Progress. My research focuses on improving robot manipulation through advanced representations of and reasoning over object affordances. For example, if we want robots to be able to assist us in tasks that involve using tools, there are a number of challenges in both how the robot can physically execute these actions and how the robot reasons over these actions to achieve the task goal. Interacting with tools involves force-based tasks such as using a screwdriver, precise actions such as turning on a flashlight, dexterous manipulation such as closing a clamp, and performing multiple objectives simultaneously and reacting to obstacles or humans in the environment while performing the task. Reasoning over how the affordances in the scene can be used to achieve a goal involves understanding the direct and indirect objects that may be involved in an affordance, such as a hammer and a nail, focusing on the actions most relevant to the goal instead of getting distracted by other actionable affordances, and chaining sequences of actions together to achieve the goal. By addressing how robots represent and reason over object affordances, we can push research in robot manipulation beyond pick-and-place actions and develop robots that are capable of using tools and reasoning about more complex goal-directed robot manipulation tasks. If you are interested in my research, please feel free to contact me. You can also find out more about the lab and our work at the Laboratory for Progress website. I hope everyone stays safe and healthy. Have a great semester and welcome to the University of Michigan.
Hello, my name is Jorge Vilchis. I am a third-year PhD student in Robotics EC. I work with Professor Chad Jenkins in the Lab for Progress here in the University of Michigan. I am interested in what is called shared autonomy and how to use domain knowledge of a human in the loop to perform tasks like object pose estimation or assisted teleoperation. One example application of my research is that making the process of assisted pose estimation more efficiently will allow to speed up annotation tasks that are essential to train data-driven models like deep neural networks or other machine learning paradigms. Another example application of my research could be a natural disaster case where you would like to have a robot to help you on rescue tasks and be able to solve any situation under this kind of scenarios. Or maybe you just want help from a robot in routinary tasks that you may face daily. The challenge under this situation is that it is difficult for a robot to resolve where objects are located and how to engage in a manipulation of them. For this, it is convenient for the robot to have some help from a human, and the help received has to be meaningful so as for the robot can finish the task autonomously. Thank you very much for listening.
Hi everyone, my name is Stanley Lewis and I'm a second year PhD student here with the University of Michigan Robotics. I work primarily with the Laboratory for Progress and Professor Chad Jenkins. My interest areas are kind of all over the place, but they're generally focused on robotic perception tasks. And at the moment, I'm spending my time looking at articulated body pose estimation, along with improving the representation of those objects for use in manipulation and affordance space pipelines. I figured now is a good time for me to briefly talk about a new project I've been working on. So if we consider a scene like the one in this picture, the robot needs to know the contents and poses of all of the objects in its workspace before it can manipulate them. There's plenty of existing works out there that accomplish this, like PoseCNN or DOPE. However, those end-to-end network-based techniques aren't particularly scalable with regards to training, especially when a task requires pose estimation for a large number of different objects. Furthermore, articulated objects are typically outside of these end-to-end networks capabilities. So what I'm working on is using a multi-view, self-supervisory trained network backbone that can improve the training time capabilities of these tasks. By leveraging multiple competing losses derived directly from general purpose tasks like correspondences or image reconstruction, we can learn a representation without having to create any human-tuned similarity or dissimilarity functions. The aim then is to produce a task-agnostic representation of an RGBD image, which improves the ease of creating an end-to-end network within the general robotics community. Additionally, we hope to later investigate the use of this intermediate representation to improve robots' manipulation skills on complex articulated objects like this gear puller in the picture. I'm glad all of you decided to join us here at UM. If you want to reach out to chat for any reason, my email is stanlu@umich.edu. Hope you all enjoy your time here. Thanks.
Hi, my name is Alphonsus Edubredu. I'm a robotics PhD student in the Robotics Institute. I work with Professor Chad Jenkins in the Progress Lab. My research focuses on planning under uncertainty and robot manipulation. My major preoccupation as a roboticist is to develop algorithms to enable robots to perform useful tasks in the home. Such tasks include cooking, packing dishes, and cleaning my bathroom. To be able to plan the actions needed to perform such tasks, the robot would have to have knowledge about the state of its environment. However, perception systems robots currently use to estimate their environment are usually noisy and inaccurate. This makes it difficult for robots to perform tasks with any reasonable level of success. More specifically, my research focuses on ways robots can plan high-level actions and low-level trajectories to successfully perform sequential tasks, even when they have inaccurate or incomplete knowledge of their environment. My most recent work focused on planning for goal-constrained grocery packing tasks when the robot is equipped with a noisy and uncertain perception system. You can contact me through email at edubredu@umich.edu or learn more about me and my work on my website. Thank you and enjoy your stay in Michigan.